Hi guys, welcome to our final lesson for Chapter 6 on solving radical equations. In Section 6.6 we're going to be taking a look at solving some of these equations that involve radicals. And so really it kind of gets into that idea of undoing to solve, and again we've done a ton of this in Algebra 1, but now we're just going to throw another feather in your cap in terms of how to solve another type of equation. First of all, for radical equations, basically a radical equation is anything that has a variable underneath the radical. So square root of x equals 12, for example, is a radical equation because it involves a radical and an x. Okay? So the steps in solving a radical equation are, first, isolate the radical. Get the radical all by itself. So if there was like 3 times the square root of x plus 5 is equal to 12, for example, we would get rid of the 5 and then we get rid of the 3, and we want to solve for the square root of x to get that part by itself. So again, we want to isolate the radical all by itself on one side of the equation. All right. Now we can either raise each side of the equation to the same power to eliminate a radical and obtain a linear, quadratic, or other polynomial equation. Basically, to get rid of square rooting, we would then square both sides because that's the inverse of square rooting. I'll talk more about some other things we can do with reciprocal powers in just a second. And then finally, solve that polynomial equation using techniques learned in your previous chapters. So again, we're going to be calling back on some ideas from previous chapters, specifically Chapter 4 and Chapter 5. All right, so a lot of stuff that's going to come back to haunt us if we have not. And then I guess the big thing here, and I can't stress this enough, guys, is you have to make sure that you check your solutions, because sometimes we get extraneous solutions with these types of problems. And again, extraneous solutions are those solutions that make sense when you solve, but then when we plug them back in, they don't work. All right? So let's take a look at a couple problems here. Let's start off with something fairly simple here. Let's start off with solving the square root of x plus 6 is equal to 3. So we write the original equation, and then essentially what we do is we square both sides of this thing. All right, now squaring undoes square root, so this is simply x plus 6, and 3 squared is equal to 9. All right, so it says square each side and eliminate the radical, which we kind of did already. And then so to simplify, we would subtract 6 from both sides, and you get x is equal to 3. So my solution is 3. So when we check that, this becomes the square root of 3 plus 6 is supposed to be equal to 3. As you know, 3 plus 6 is equal to 9, and so when I take the square root of that, my solution does check. All right, so why don't you guys try the checkpoint problem at the bottom of the page. We'll be right back with a solution. All right, so here we're going to take away 1 from both sides. We get the third root of x minus 5 is equal to negative 2. So just like here, to get rid of square root, we squared. So to get rid of cube root, we're going to cube both sides of my equation. Cubing and cube root undo each other, as we know from inverse functions from last section. And so this becomes x minus 5 is equal to negative 2 cubed, which is negative 8. From there, we'll add 5 to both sides. Negative x equals negative 3. All right? Now, we need to check that solution, so this becomes the third root of negative 3 take away 5 plus 1 equals negative 1. All right? Now, this becomes the cube root of negative 8. Now, can you take the odd root of a negative number? Absolutely. You just can't take the even root of a negative number. If this was square root of negative 8, we would be stuck and our solution wouldn't work. So this is the third root of negative 8, which is negative 2. And then negative 2 plus 1 becomes negative 1, and that's what we were supposed to get. So my answer does check. All right, let's try another one here. We need to talk a little bit more about reciprocals. Now we're talking about rational exponents. So my exponent here is 2/3. So we have to remind ourselves, what do we multiply 2/3 by to get 1? Well, that's called the reciprocal, or also what we refer to as the multiplicative inverse. So we know also that if I have a to the m to the n power, we would multiply those exponents and make it a to the m times n. So to multiply two exponents, we have to raise a power to a power. And so if I want to get rid of raising this thing to the 2/3 power, what I'm going to do is I'm going to say this is now 3x plus 4. This is to the 2/3 power is equal to 16. And what I'm going to do then is I'm going to raise both sides to the reciprocal of 2/3, which is 3/2. Now you might ask, why are we choosing 3/2? Because when I do power of a power here, when I multiply the power of a power, when I raise a power to a power rather, I'm going to multiply those exponents together, and so 2/3 times 3/2 becomes 1. And so now we simply have 3x plus 4 all to the first power. Well, who needs the parentheses then, right? Now on the other side of this, this is then 16 to the 3/2 power. Well, properties of exponents says that this is then the square root of 16 to the third, because it's square root of 16, and then raise that to the third power. Well, as you know, the square root of 16 is 4, and 4 cubed is 64. And so this simply becomes 64. All right, we've already simplified, kind of did that off in the margin over here. And so now what we're going to do is we're just going to subtract 4 from both sides. You get 3x is equal to 60. And when I divide each side by 3, you get x equals 20. All right? Now, my solution is 20, and I do need to plug that back in and check. So we're going to take a look at that over here. This is then 3 times 20 plus 4, all underneath, or I'm sorry, all being raised to the 2/3 power, and it's supposed to be equal to 16. Okay, this is 60 plus 4, which is 64, all being raised to the 2/3 power. As we know, the 2/3 power is the cube root of 64, then squared. Cube root of 64 is 4, 4 squared is 16, and so we're in good shape there. All right? So now we're going to take a look at one where we get an extraneous solution. Again, extraneous solutions are solutions that make sense when we do the math, but they don't make sense when we plug them back in. To solve this, we're going to go ahead and square both sides, because that's going to get rid of square roots. Now you got to FOIL this out over here. All right, you can't just say x minus 2 squared. So x minus 2, however you choose to do that, that becomes x squared minus 4x plus 4. Again, if you choose to use FOIL or Punnett squares, or just remembering the pattern of the square of a binomial. On the other side, when I square the square root of x plus 10, I get x plus 10. All right, so we've already expanded the left side and simplified the right side, so we're going to put this in standard form. Again, to solve anything with an x squared, we have to get all of our stuff on one side. So we're going to minus x and minus 10, minus x and minus 10, and so this becomes x squared plus 3x, and then minus 6. All right? Sorry, this was negative, this is negative, so it's supposed to be minus 5x. Let's fix that real quick, otherwise we're going to have some difficulties when we get moving here. All right, so again, this was negative 4x minus 1, where it becomes negative 5x. All right, now, fortunately for us, this does factor. We need two numbers that multiply to negative 6 that add to negative 5. Those numbers are x minus 6 and x plus 1, because negative 6 plus 1 is negative 5. So there's my factored version. I don't have to do snip method because the leading coefficient is 1. I don't have to use the quadratic formula because it does factor. So either x minus 6 is 0 or x plus 1 is 0. Subtract 1 from both sides, you get negative 1. Add 6 to both sides, you get 6. So let's check that x equals 6. This becomes 6 minus 2 is equal to the square root of 6 plus 10. Well, 6 plus 10 is 16, and the square root of 16 is 4. On the other side, 6 minus 2 is 4, and so 4 does equal 4. And so the solution that is the 6, this one's okay. All right, let's try our negative 1. All right, negative 1 minus 2 becomes negative 3. And on the other side, this is the square root of negative 1 plus 10, which is 9. So this is the square root of 9. And as you know, the square root of 9 is 3, and 3 does not equal negative 3. And so we have to reject this solution. So by rejecting that solution, we say the only solution is the 6. The apparent solution that we found of negative 1 is extraneous. It doesn't check. All right, so on the top of the next page, let's talk about solving another one of these. Now, we have two radicals in this problem, which could potentially lead to a big old mess here. But we have to first say, look, if I subtract the 2 and bring it over here, that 2 is going to be an issue on one side or the other. So unfortunately, we're going to have to just deal with it and say, look, I'm going to square both sides of this. All right? Now, this becomes essentially like a binomial, a plus 2 squared. The only difference is now the a is the square root of 6. So I'm going to multiply the square root of x plus 6 plus 2 times the square root of x plus 6 plus 2. Well, square root of 6 plus 6 times the square root of x plus 6 becomes the square root of x plus 6 squared, which, as you know, effectively cancels out, and I'm left with x plus 6 in the first box. In this box becomes 2 times the square root of x plus 6, 2 times the square root of x plus 6, and then 2 times 2 is simply 4. So when I combine like terms now and kind of simplify this thing, I get x plus 6 plus 4 times the square root of x plus 6, because I have 2 of them here and 2 of them here. And then I still have this plus 4 on the end. On the other side, when I square this guy, I simply have 10 minus 3x. All right? Now, we're going to combine like terms here kind of in one step. This is 6 plus 4, which is 10, so I'm going to minus 10 from here and minus 10 from here, which conveniently cancels all the numbers out. We're also going to subtract x from both sides so that we can get that. Again, our goal is to simplify and get that radical all by itself, so we're going to minus x from both sides. And so we get 4 times the square root of x plus 6 is equal to negative 4x. Okay, now we're going to divide both sides by 4, and I get the square root of x plus 6 is equal to negative x. All right? So now what's our next step? Now what we have to do is we have to get rid of square root again. So we're going to square once again. Square root of x plus 6 squared is simply x plus 6. Negative x squared, well, negative x times negative x is x squared. So here's what we're going to do. Now we've got to kind of get us all the way down here so that we can get this in standard form, because again, the only way to solve something with second degree is to get everything on one side. So I'm going to minus x and minus 6, minus x and minus 6, and I get x squared minus x minus 6 is equal to 0. All right. Now again, conveniently, this does factor any two numbers that multiply to negative 6 that add to negative 1, because again, that's negative 1 there. And so my two numbers that multiply to 6 that add to 1, we've got 1 and 6 and 2 and 3. To get negative, I need one of each. And it looks like if I choose that pairing, 2 and negative 3, I'm going to be in good shape. So this is x plus 2 and x minus 3. So my solutions are x plus 2 equals 0 or x minus 3 equals 0. So my zeros are negative 2 and positive 3. All right? Okay, so now let's go ahead and check these. And again, I'm going to have to move my board here to get down to the check step. So let's clear this out of here and slide on down. And once again, we'll fill this back in. Our two solutions as we had them were x equals negative 2 and x equals 3. All right, so let's check the negative solution first. I'm sorry, let's check the positive one first because I see the negative down here. So let's check x equals 3 first. To check the positive one, this becomes the square root of 3 plus 6 plus 2 is supposed to be equal to the square root of 10 minus 3 times 3. Again, my original functions were the square root of x plus 6 plus 2 and the square root of 10 minus 3x. So this becomes the square root of 9, which is 3, and 3 plus 2 is 5. On the other side of this, this is 3 times 3, and 3 times 3 is 9, so this becomes 10 minus 9, which is 1, and so the square root of 1 is 1. Obviously, these are not equal to each other, and so we're going to reject that solution. The parent solution of 3 is extraneous. All right, let's try the negative 2. The square root of negative 2 plus 6 plus 2 is equal to the square root of 10 minus 3 times negative 2. Well, negative 3 times negative 2 becomes positive 6, so this is 10 plus 6, so this is the square root of 16, which is, you know, is 4. Let's work the left side now. This is negative 2 plus 4, which is, I'm sorry, negative 2 plus 6, which is 4. Square root of 4 is 2, and 2 plus 2 is 4. And so the negative 2 is a good one. The positive 3, that's extraneous, so we have to reject it. All right? And so the only good solution is the negative 2. The apparent solution 3 is extraneous. That concludes the lesson, but we've got 3 checkpoint problems here. We're going to go ahead and see if we can't get through a few of them. So try the checkpoint problems. We'll be right back with solutions. All right, for number 2. We're going to add 21 to both sides because, again, we have to isolate the rational exponent here. So this becomes negative 2x to the 4/3 power is equal to negative 32. Divide both sides by negative 2, and I get x to the 4/3 power is equal to positive 16. Now, we're going to raise both sides to the 3/4 power because that's the reciprocal of 4/3, and effectively that's going to cancel out, and you're going to get x is equal to. Now this becomes 16 to the 3/4 power, which is really the 4th root of 16 cubed. Well, the 4th root of 16 is 2, and so 2 cubed is equal to 8, and so x is equal to 8. All right, I'm not going to take the time to check that answer. I will tell you that that answer does check, all right, but that's a good solution. All right, for number 3, you will get an extraneous solution. Let's take a look at that one. For number 3, you have to first square both sides of this. So this becomes x squared plus 4x plus 4, because again, square of a binomial becomes this, is equal to simply 2x plus 7 when I square it. Now we're going to get everything on one side, so minus 2x and minus 7, minus 2x and minus 7. So I get x squared plus 2x minus 3 is equal to 0. Now fortunately for us, this does factor nicely. We need two numbers that multiply to make negative 3 that add to make 2. Well, two numbers that multiply to negative 3 are simply 1 and 3. We need negative 1 and positive 3 to make positive 2. So this is x minus 1 and x plus 3. So my two solutions are x equals 1 and x equals -3. Now when I plug those back in, this becomes 1 plus 2 equals the square root of 2 times 1 plus 7. Well, 1 plus 2 is 3. Under here, 2 times 1 is 2, plus 7 is 9. Is the square root of 9 equal to 3? Absolutely. So this one is okay. Now let's try the -3. -3 plus 2, are you guys seeing a potential issue here? Yeah, you're going to get -1. And the square root of 2 times -3 plus 7, this becomes -6. And -6 plus 7 is 1. The square root of 1 is 1, which is not equal to -1. So for this one, we have to reject. All right, so that's not a good solution. That's an extraneous solution. And finally, let's take a look at the last one. And the last one, this is that idea where you're going to have to square this thing twice. So we're going to square and square. When I square the square root of 3x plus 4, I have to use a Punnett square. If you can't do this by using our properties of square of a binomial, which is kind of tough to do. So this becomes the square root of 3x plus 4 squared, which as you know is going to be 3x plus 4. This is -1 times the square root of 3x plus 4. This is -1 times the square root of 3x plus 4. And -1 times -1 is +1. So on the left side of this thing we have 3x plus 4 minus 2 times the square root of 3x plus 4. And then we still have that lonely plus 1 on the end. And when I square this side, we get simply x plus 5. Combined like terms over here, this is 3x plus 4 and then plus 1. So 4 and 1 makes a 5. So we're going to minus 5 and minus 5. And thankfully that all cancels and this is gone. We're also going to minus 3x from both sides. And I get -2x over here. On the left side, I get -2 times the square root of 3x plus 4. We'll then divide both sides by -2. I get the square root of 3x plus 4 is equal to x. By squaring both sides, I'm going to get 3x plus 4 is equal to x squared. I'm kind of running out of board, so we're going to slide back up over here in the margin of your paper. You get then 3x plus 4 is equal to x squared. When I minus 3x and minus 4 from both sides, you get x squared minus 3x minus 4 is equal to 0. Now once again, we've chosen something very nice that factors. This ends up being x minus 4 and x plus 1. And so my solutions are x equals 4 and x equals -1. Now when I go back and I try those, this one is going to work, this one's going to be okay. And then when you plug in -1, that's going to be an extraneous solution. So we're going to reject the -1 and we're going to keep the 4. All right. Now again, that requires you to plug those values back in, but that's effectively what we do for that lesson. All right. So that's solving radical equations, and that concludes lesson 6.6.